Stop sharing. It's weird. Okay. So because of that, it's not unusual. Okay. So we have this part done. So now it's the same problem essentially, but the z-score is 3.2. Right away, you can tell this is actually an unusual. This is going to be unusual because the z-score is greater than 3. It's either if it's greater than 3 or less than, if it's greater than or equal to 3 or less than or equal to -3, then it's unusual. Okay. All right. So here we have 3.2, right? It's the same problem as before, except here we were given 0.75. Here we're going to have 3.2. So we want to solve for x. So from here, what do? We're going to multiply both sides by 14, right? Because again, we want to isolate x. We want to get x all alone. This will kill off the 14, okay? By multiplying both sides by it. On the left, you have 44.8. And that's equal to x minus 125. Okay, so what comes next? Well, next, what we do is we add 125 to both sides. Right? Because again, we want x all alone on one side of the equal sign. And by doing that, we get 179.8 equals x. That's what x is. And again, this is unusual because this z-score is bigger than 3, or it's less than -3. You know, in other words, if the data value, if it's more than 3 standard deviations away from the mean, it's unusual, which really means that the z-score is bigger than 3 or less than -3. Okay, now before we do part C, are there any questions about this? So for the last one here, we want to know what percentage of males, okay, has blood pressure less than 160 millimeters, has systolic blood pressure less than that. In other words, what percentage of the data values are less than 160 millimeters? Just like before, we get the z-score, right? So here we don't know z, but we have x. Right here we didn't know x, we had z. Well, here we're basically switching roles in a sense. We have 160 minus 125 over 14, right? And that turns out to be 2.5. So the z-score is 2.5. So we want okay, now again, we're looking for the data values less than, right? Less than, meaning we want the area to the left, less than this z-score. So how do we get that? Well, we can go to the table. In fact, let me do that. Now, if you look at 2.5, which is, where is that? Over here, it looks like. Okay, hopefully you can see it there. You can see that for the area to the left, area less than, right? Again, this is all values. This is the area to the left of the z-score. The area to the left is 0.9938. Area to the left, 0.9938. So it's 0.9938. So because of that, that tells us that about 99.38% of all males have a systolic blood pressure less than 160 millimeters. In other words, 99.38% of the data values, approximately that much, is less than 160. Any questions on that? Okay, so that's area to the left. How would you get the area to the right, though, or greater than it? Right here, we want area to the left of z. We know how to get that. We can use the table, and I think later today, if not today, then definitely Friday, I'll show you how to use Desmos to get it. Although that's a lot easier than using the table. So this is the area to the left. How would you get the area down here? Well, keep in mind the total area under the curve is 1. That's the total area. So to get this piece, what we can do is subtract this piece off that is subtracted from 1. Okay, so again, we could take the whole area, throw this piece away. We're going to be left with this piece. So it's 1 minus the area to the left of z is what I'm trying to say. So whatever is in the table, you do 1 minus it. That's really what I'm trying to say. So as an example, this was actually an earlier example that we did. You know, with the certain dog breed, the weights of dogs of a certain dog breed, the weights are normally distributed with a mean of 62 pounds and a standard deviation of 6 pounds, right? Well, let's find the percentage of data values, okay? Or the percentage of dogs that weigh more than 55 pounds. Let's find the percentage of data values larger than 55 pounds. Okay. Well, here we don't want less than, we want greater, larger to the right. But we still have to find the z-score. So the z-score we have here, again, the mean, if I can find it, the mean is 62 pounds. The standard deviation is 6. Our data value is 55 pounds. So for the z-score, we have 55 minus 62 over 6. Okay. So, you do this, and the z-score turns out to be, approximately negative 1.17. Okay. So what is the area to the left of negative 1.17? Well, again, we can use the table. But if we went to the table, we would have to use negative 1.2 because negative 1.17 is not in the table. In fact, let me show you. Right, negative 1.17 is not in this table. Okay, as you can see, negative 1.17. But what we can do is round, and we can round to negative 1.2. As you can see, we get this, 0.1151. But remember, this is the area to the left of that z-score. How do you get the area to the right? Well, I said it already, and also it's up here, as you can see. It's going to be 1 minus the data value in the table. That's what it is. It's 1 minus the area given by the table. So we want 1 minus this area. So that's what we're after. 1 minus that area. Here we go. right? So the area to the left of that z-score, negative 1.17, approximately here, the area to the left is 0.1151. So the area we're looking for, which is shaded in, okay, that's this. 1 minus that, which is 0.8849. So the percentage of data values greater than 55 pounds, it's about 88.49%. In other words, the percentage of dogs, the approximate, I should say, percentage of dogs that weigh more than 55 pounds is about 88.49%. So it's just 1 minus the area, 1 minus the data value. That's what we're looking for. All right. Okay, are there any questions on this? Okay. All right, so going back to another example, going back to an earlier one as well.